Hey everybody, this is Larry. This is me going with Q4 of the Trionic, Q4 of the weekly contest 461 Trionic Array 2. Hit the like button, subscribe button, join me in Discord. Let me know what you think about this one. I think this one, it can be intimidating, right? But I think this one is a good practice in breaking things down and try to figure out what they're asking. It took me about something like 24 minutes or 25 minutes in doing so. So definitely still a little bit tricky, right? And for now, let me bring up my drawing board. Yeah. And the question is that basically you have some. This is I think a very reasonable problem for relative beginners, because I think the tricky part about this is about the analysis, right? And in that sense, it's a good problem because I feel like in theory most people have the or most people have the like the ideas and stuff like that to come up with it, right? It doesn't require anything too crazy. Like yeah, maybe the implementation is very messy and you may have a lot of wrong answers or something like that, but the ideas I think are very fundamental to just like regular problem solving, right? Like there's nothing tricky per se. You just have to kind of be able to prove yourself every time. And this is one of those problems that in a fun way, if you prove yourself or if you do proofs, the proofs will allow you to write easier code, right? And not trip over yourself a little bit. And what I mean by that, maybe I'll talk about in a little bit. But for now, basically the idea behind this problem is that you have a whole array. You want to find out some maximum sum of this thing, right? And n is 10 to the fifth. It's pretty big. So you have to be able to do it in faster than n square, or yeah, faster than n square, right? So then, yeah, with n square off the table, then the first thing that you have to think about is not necessarily greedy, but some sort of thing that allows it to be O of n or O of n log n, right? Some kind of property. The first thing I notice is the strictly decreasing part, right? And what I mean by that is that if you look at when you watch the problem, there's a strictly decreasing part. And from that, what I mean is that, okay, so I actually kind of visualize this as like, okay, let's say there's an array, and then there's some chunks that are, going up, going down, going up, maybe flat, like basically delta of 0, right? They're equal. And then maybe going down, up, down, dot, right? So there are a couple of observations once you kind of draw this out. The first thing that I realized is that, well, in this particular problem, each element can only be in one thing, right? And what I mean by that, right? I mean, I don't know what I mean by that. I think that's pretty straightforward, right? Each element cannot be in two parts. I mean, okay, I know that technically speaking, the P and the Qs, they're in both the middle chunks, but for the most part, either way, you could say, okay, fine. Maybe the P's and the Q's, the pivot point, the mountain elements, the peak elements, the peak and the valley elements, they can be in two parts. But for the most part, every element is in one chunk, right? There's no decision, no choices for the numbers to go. So then now you basically, when you draw it out, you have something like this, right? And then, so from that, I was like, okay, well then, just honestly, part of the tricky thing about this problem was me just convincing, like, okay, I'm not missing or misunderstanding something, right? Because then now, you just have to kind of figure it out by I wouldn't say case analysis, but look at every possible thing, right? Okay, let's remove this thing because it makes out so I don't have to draw more. So let's remove this real quick, right? What I mean by that is that then now you can just consider every 3 consecutive things, right? Chunks, if you will. I call them chunks because I don't know, right? Like this is up, down, up, which is what we need. And then also, maybe later on, this is up, down, up, right? This is what we need. And of course, if we had a flat thing here, then of course it breaks it because you only look at 3 things at a time and go, nope, right? But for now, you can say that it goes this way. But again, the reason why this is fast enough is because, well, let's look at the starting with the decreasing piece, the middle piece, right? Well, the middle piece can only be in one segment if you kind of look at it this way. Like in the worst case, it is just going to be a chain that looks like this, right? With one element overlapping, something like this, right? So if you, right? And that means that the middle element, the down element, will always only be in one piece. That's the first observation. But also in the same way, the up element can only be in two pieces, right? At most. It could be on the right side of a piece, or it could be on the left side of this piece, right? So, okay, so what does that mean? That means that even if you do some linear like scan thing, like let's say you look at every chunk or every 3 chunks, and then you do some linear thing on the 3 chunks itself, it is going to be linear, right? Because each element can only be looked at twice, one from the left side and then one from the, well, I'd say from the right side, but you could say from the left side of the chunk, right? So that's basically the core idea. And once you get that, I think the rest you can kind of figure out. Feel free to, I don't know, but feel free to pause this video and then kind of, try to see if you could guess what I'm going to say, right? Or even solve it really, and then come back and then say hi. but yeah. But then now we're trying to maximize. So then now we have all these chunks. Okay, and then we're trying to figure out, well, we have to try to find the maximum 3 chunks together. That's one. And part of that will be for each set of 3 chunks, we want to maximize the sum, right? Because given these 3 chunks, well, let's go through it, right? Actually, let me just rewrite it. So given these 3 chunks, let's use a different color. Right, so you have something like this. And keep in mind that here, well, the middle, there's no degree of freedom, right? And what I mean by no degree of freedom, it just means that you have to take every element. You can't like skip one, because if you skip one, then it breaks the chunking. So you have to take every element. On the left side, though, we don't have to, and also on the right side, right? Because you can imagine just that if we cut it off at some point, it is still true that this is going up, and also the same thing here, right? So, you just need the chunk that is connected to this, right? So you need, and that's basically the core idea. And there are ways you could probably play around with binary search, prefix sum, and etc. And I also thought about those and tried a little, or I even implemented out the prefix sum without thinking about it, because anytime you want to take a subarray sum, it comes in handy. But in this problem, you don't even need it. The reason is because then now you can just brute force a linear scan of the left side and the right side. And what I mean by that is just very straightforward. We go, okay, well, what if we took, let me use another color. What if we took 1 element? What if we took 2 elements? What if we took 3 elements? 4 elements, 5 elements, right? And you just add it all up in a prefix sum kind of way, but just a cumulative sum, right? Meaning you take the first element, does it make the number bigger? Yes, keep it. Second element, does it make the number bigger? Yes, keep it. Third element, does it make the number keep it, right? And looking at the left side, as soon as you see a negative number, that means that everything after that is going to be negative, so you could throw it away. So you could use that kind of logic, that kind of heuristic to be like, okay, well, as soon as we see a negative number, let's go home, right, on the left side. You don't even have to do that. You can just take the max over all of them, right? You could say, okay, well, we have the sum of the first, not the first 3, but the closest 3. Is that bigger than our running sum? The first 4, or the closest 4, the closest 5, the closest 6, right? So you have all these numbers, you sum them up, or you have all these sums, you sum them up and just see if it's bigger than your numbers, right? And that's it. Same idea with the right side. Maybe there is a little bit trickier than the other side, because you cannot do like the early termination thing, but it doesn't matter, because you can just brute force going, okay, if we take 1 number, what is the sum? If we take 2 number, what is the sum? If we take 3 number, what is the sum? for a number, dot, dot, dot. And of course, you could calculate this in a cumulative, you could say maybe a sweep line, even if you want to call it that, I don't know. But it's just like a cumulative sum kind of way. So you could do this in linear as in the size of this chunk, right? And keeping in mind that it can go, you have to do it because, maybe you don't have to, but it's easier. Maybe there are ways to do it. But what I mean by that is that, like, you know, for example, this point could be like a negative 100, and then you go negative 90, negative 80, and this is increasing, right? Dot, dot, dot. But then you could, but you may figure out that, you know, you know, there may be a billion, and you always want all the positive anyway. So maybe you could do some maths on, like, you know, okay, you sum up all the positive numbers and then try to figure out if it's worth going or something like that. I don't know, right? But for me, it's just easier to go, okay, well, the cumulative sum here is negative 100, negative 190, no, dot, 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 and then at some point, if you have a cumulative sum of a billion, then you're like, okay, well, we'll just take code for that long. And this is all just a regular loop, right? And that is basically the problem. Yeah, that's basically it. And we can go over the code. Actually, honestly, my code is really ugly because I knew I was right, but I also knew that it was like a sort of not quite data structure, but data representation problem. So I did want to be like, just get it over with a lot of if statements, and that's what it looks like. And the way that I represented it is that I have, yeah, I mean, all right, let's go start from the beginning. I have prefix sums, not necessary, but I did use it, but it was not necessary because if we kind of go, I think the way I used it was that I just used it for the middle chunk because that's easy to calculate. But it's not even necessary, right? Because as I said, the middle chunk will only be in one set of 3 chunks, so you could just do a for loop to add this, and that's fine too, right? You don't need prefix sum. Anyway, but I did do it anyway during the contest. And then here I set a sentinel, and here I have 2 things, right? So streaks contains a list of streaks. And the way that I did this is a little bit wonky, forgive me. I don't know. I just thought as long as I'm consistent, it's fine. Current contains a weird data representation, right? Representation. So current sub 0 is the direction. And I think in normal times, you probably wrap this in an object, by the way. I just kind of, I was like, I just want to get it hanging. Direction. Meaning that if it's 1, it is increasing, negative 1 is decreasing, and I guess 0 means equal, right? Oops. I mean, yeah. And then current sub I, where I is not 1, or not 0, sorry, contains 2 numbers. We have current sub I of 0 is the index, current sub I sub 1 is the number. I don't know that. I think I just kind of. Honestly, I don't need the index for this. I think I used it because I used it to get the prefix sum, but actually it's not necessary. Like I said, I was just doing this really freehand, and the code is ugly. But yeah. Okay, and then basically this is just case analysis from that. Is that we basically want to group we just have to calculate all the chunks. You have increasing chunk, decreasing chunks, and so forth, and that's all I'm doing, right? So then now for every number, I look at to see if it's increasing or decreasing, or equal. If it's increasing, I want to check with the last, like, can we add it to the last chunk or the current chunk, I suppose. Yeah. So then I added the current chunk. Otherwise, I still add it to the current chunk, but then I end the chunk and I create a new chunk with that means that the previous chunk was, I don't know, either down or equal, it doesn't really matter. But we create a new one where it is increasing, because now it is increasing. We set delta is equal to 1, and then we just kind of put the numbers in, the first number in. Same thing for going down, really, -1. I mean, it's very ugly, I'm not gonna lie, but I was like, I don't think this is too bad. Or too bad for one use, right? And then this is just 0. I don't think you need anything for 0. You just kind of end the streak. I don't even keep track of the number because you don't use the 0, the equal in any way, right? There's no party of 3 chunks where 0 is one of them, so I just kind of ignored it. You could probably put it in for safekeeping. And then of course all this we look at I compared to I plus 1. So here we need another I plus. So you need to keep track of the last element. That's it. If the last element is increasing, we'll add it to streak. If it's decreasing and the last chunk is decreasing, we'll add that to the streak as well. And that's basically it. Keeping in mind that for this one, when you have a pivot point, the current number is part of the previous chunk and the next chunk, right? That's just the way it is structured. But yeah. Whew. All right, so really bad data representation, but it works enough. Hope this is my shame. Hopefully not your kink, but yeah. In any case, yeah. So then now we just look at every 3 chunks. We just look at every 3 chunks. We go, okay, if this chunk is increasing, next chunk is decreasing, next chunk is increasing, and we have at least 2 elements in case, I don't know, in case there was some weirdness. But yeah, you need at least 2 elements in each chunk, even including the dupes, but also keeping in mind that for me, the first element is, the delta element, so that's why it was less than 3, we just skip, right? Yeah. And I think it's impossible for the middle chunk to have less than 3 elements, because that just doesn't make sense. You need 2 numbers for it to be decreasing. That's why I didn't check for it. Okay, so middle has to be considered. I don't know what that means actually. But yeah, I mean, I don't know why I wrote that actually, but or maybe I wrote that like you just have to take the entire part. I mean, that's what I think I meant anyway, because that's what I was thinking. So yeah, you have to take the entire chunk. Like I said, I added a prefix something, but you could just do a for loop because the middle chunk can only be in one place, right? And the left sum is what I said, right? I do spend time cutting it off, so I go from the right side in, so that means that I'm getting the bigger number to the smaller number. So when it's decreasing direction, even though it is going up, so that means that as soon as we see a negative number, we are no good. But yeah, and also we start this at the first number because we need the number. Technically, it's the first 2 number, but then because the first number is actually the pivot, and the pivot gets counted twice in this. Well, like you don't want it to double count it, so we subtract it, and so that's why there's only the second number of the left side. And yeah, you just go down the list. You're bueno. And on the right side, it's a similar idea, but like I said, you could actually use this on the left side as well, but I just did the left side first, so what made sense for me on the left side, I'm like, oh, this doesn't make sense on the right side. How do I solve it? Now just like, you could watch the live portion, and I was just like, oh, actually, I can just do a for loop, which is what I do here, right? So I take the cumulative, right sum is the cumulative sum of every number as part of that chunk. And then right sum max is just the max of the cumulative sums. And then, yeah, and then the best answer is just going to be the left sum plus the middle sum, and then the max of the right sum, the way I have it. And that's it. That's what I have for this one. Yeah. It is going to be linear, right? Like I mean, I always show this linear. Each number can only be in one chunk, and each chunk can only be at most part of the 2 calculations, so that's linear, right? It's constant per chunk, so linear for each element, or linear for the entire array, sorry. And so it is linear time and linear space. And yeah, and I'm gonna make this smaller so you can maybe see all of it, though like I said, I don't think this is reference code. This is probably one of the chunkiest code. I just own it. If you say that I wrote this, I lied. I copied it off ChatGPT. That's how shameful I am on this code. No, I mean it works, right? If it's stupid and it works, it's only slightly less stupid. But it is way bad code. But yeah, that's all I have for this one. Let me know what you think. Thanks for watching, and yeah, you could watch me solve it live during the contest now. The issue. Okay, fine. I mean, I don't even know anymore. All right, let's do Trionic array 2. This is the same one, I assume. Maybe let's see what's different about it. All right, Maximum sum. Okay, that's different. Trionic subarray. There exist. Seems annoying. A good amount of people got it. I mean, I don't know how to do it yet, but I assume there's going to be prefix sum. Just subarray sum in general. Oops. And then now what? Do I check for an existence? But even then, that's n squared. You check every subarray, and you're able to check where. Okay, well. How do I think about this one? I mean, people got it in like 1 minute, which sounds yeah, that's why no one does Leetcode anymore. The leaderboard is dumb. At least have trusted users or something. I don't know. But in any case. Are there always a trionic number? Oh, okay, that's what I was gonna say. I mean, I did say yes, but I was like, why? When you return -1 or something? All right. Do I have any ideas? Not at all. So we can construct all. Okay. So the thing about this part is that the decreasing part, there's no choice, right? You cannot shrink it, but then the increasing parts. The increasing parts are interesting. The increasing part you actually always want to add more, and for the most part, there's like weird cases with negative numbers, right? Yeah, but you have no choice on decreasing. On increasing, you also have a choice on adding. So then is it that for every, and by definition, you could binary search on the increasing side, right? How long to go? No, I mean, you don't even have to. It's greedy, right? Why is this hard? Well, I'm trying to figure out why this is hard. Or am I missing something obvious? But it's just greedy, right? Yeah, because you just go through the entire thing, right? So, okay. How do I want to represent this? It's just so awkward. Okay, fine. Everything is more data structure than anything, but we guess we'll see. Then now, we want to say. And then if two numbers are equal, it breaks the streak even, right? So, which makes it easier to solve, kind of, but it doesn't really change. I mean, it's not that hard anyway, but complexity-wise, I don't know if I can do it, but we'll see. So if this is less than, we want to say, let's just say there's a +1. Let's just say streaks. So then this is a -1, right? So I'm just gonna write it dumbly. Is that how I want to write it? It's so messy. Okay, so let's just say we have. Okay, so then now we write. Okay, so then if maybe something like this, maybe. Except for we want to say, I don't know. We're gonna do a number of things. Maybe we'll just put in the first element. I don't know. Just to kind of for visualization. This is definitely very hacky right now. I mean, you could also just use it as a enum, I suppose. And then otherwise it's a 0 and we just don't care, right? Do we care? I guess not. But on the delta, we actually want to, I mean, we start a new streak, but also want the old streak, right? So actually we maybe, oh, I think I forgot to do something, which is that, yeah, okay. Like I said, this is pretty bad. I guess in this case, then we actually want to do delta 0 to 0. So then we do, we have to reset or something. And then we just ignore it, right? So then now, let's see if I parse that correctly. Didn't even write the code correctly. I don't know if I need the prefix. I probably do. So okay, so this is just very wrong. We have a 1. Oh, because delta is -100. Huh? Oh, I guess we have to do streaks. Oh, and here before we set it, streaks. Okay, and then at the very end. Yeah, whatever, streak start of end current. Oh, current doesn't mean anything, that's fine. I meant this one. Okay, so then now we book it into 0. And then this is decreasing, so did I do something wrong? Decreasing, oh, I did do it wrong. I got the deltas wrong, okay, fine. Whoops, I suck at math. Second time I failed at science today on less than equal to. Okay, so now, yeah, 0, -2, -1, 1, and then -1, 3, right? Okay, so then now, yeah, I don't get what's tricky about this necessarily, but then now you want to see how far you can extend, which can either do do I even need to though? This is very weird. Well, let's see if I can get the right answer, and then we'll think about optimization afterwards. Not super. Oh man, my monitor was not bright, and I thought I was just drifting into darkness. But yeah. Okay. So. Right. So. So then now if streaks of I of 0 is equal to negative. Wait, what? Shouldn't it be increasing? 0 could negative 2 is decreasing, so okay, but that's not what we want. Then now we only get this, right? I don't know. I mean, I need to store more stuff in here. I think that's the TLDR, but I also have to do like some magic. I mean, I think we should just keep track of the index, but it's just the way that I did it does not make it easy. Okay, fine. I don't even know that I need the number, honestly. Maybe I do, but zeros we don't care about because they'll never be triggered, hopefully. What? Oh yeah, I didn't. Oh, didn't even print it. Okay. So then now we can get okay. We're gonna get max, right? Actually, I guess negative infinity. Okay, so we have to consider it. So then that's just first element. First element is the left index. Right index. The last element, first element. Okay, and then now it's just prefix sum. So yeah. Right, okay, because you want to print that out. Just to confirm, I mean, it should be fine. Oh yeah. This shouldn't be, something is wrong. It's, oh no, it's, okay, yeah, no, it's right. I was reading this wrong. It's -1 plus -3, so 2, okay, so I think this is right. This is 4 plus 2, I forgot that these are the indexes. Okay, and then now we have to try to figure out the left and the right. I mean, each number can only be in 2 parts, right? So I don't get why you can, there's no way to do n squared, right? Each number can only be in 2 pieces, so the middle can only be given the middle one, so the prefix sum might not even be necessary. But okay, so then now just go left sum is equal to streaks of I of the last number, right? Well, it has to be this plus, has to be 2 numbers, right? So okay, so I'm a little bit off in that. I think I have to do some more if statements here, but that basically if length of streaks of I, the first element is a placeholder, the second, so it has to have at least 3 elements, so if it's less than 3, continue. And the way I represent data is terrible. do not try this at home. Okay, so then now left sum is at least this, right? So then while j is equal to length of streaks of I, not while, but this is true. -1 is the last element, -2 is the second element, so -3. So while j is greater than 0, and we don't want it to be 0 because that number doesn't do anything, so streaks of I sub j of 1. If this number is greater than, or maybe you go to 0, it shouldn't matter. Left sum, we add it. And then, yeah, and then we just kind of j, right? We'll put left sum. Streaks of I. Okay. Left sum, this is, yeah, I mean, yep. And then now right sum is the same, kind of. It's I plus 2. The first element. I mean, it's so easy to get index 1. That's why you should use objects, but the reason why I kind of hesitate is because Leetcode is bad, so so that may actually cost you time in Python, and that may actually mess things up, which is a really silly thing to say. But yeah. Oh, this should break. I mean, I don't think it matters because it's sorted in a way. And here, yeah. Actually, the second part, this part is the tricky part actually, because if you're going to negative, so I can't do it in the greedy way. The first part, let me double confirm that you should be able to do it in greedy because it just goes smaller, so you're doing it the right way. But this part actually is not trivial. This is needed, but then now we go. Okay, I mean we just loop over it actually, right? Okay, that's fine. Yeah, yeah. And then now we want to say, I guess we didn't need the prefix sum, but j sub 1, right? So right sum, right sum max. Okay. And then now press max press left sum plus mid sum, I forget, middle sum press right sum max, and then return best, right? Something like that. I don't know why I look so weird on this one. Okay, yeah. We have to write max. That's no Gucci. I did not do. No, there's always an answer, so I'm doing something wrong. 1427. What is wrong? Do we just not go in? It's less than 3 or less than. Not enough. What does that look like? Why does this take so long? Leetcode. So we okay. Okay, so this looks like missing a 7. That's why. Oh, because of the last number. Oh yeah, okay. I mean that's fixable. What am I doing with the last number? Okay, so then Yeah, I just didn't do the last number. That's fine. Okay. There's at least 4 numbers. Okay, so this should always exist. Okay, it's increasing. Yeah, this is so awkward. Okay. Oh, maybe I'll just write. No, I have to do it because it's only for one thing. Okay, I mean, okay, you got this, Larry. This is almost the end. Okay, so if this is the case. No, okay, I think it's too confusing. Let's just do it this way. Append. So that means that is this increasing. So we increase it by nums of n-1, and we're done, right? Else we start a new thing, but we can't start a new thing anyway, so it's fine. Okay. And if it's equal, then what happens? I don't know, Larry. Stop asking me questions. Because then it ends and then you start a new streak, but that streak can be considered anyway because it's too short. Because you only have one element. So that's why. Maybe that's good enough. I honestly don't know. 20. 20 is definitely not right. -8 also not right. But it doesn't crash, so that's good. Okay, so that means that I can maybe print here. Streaks of I. Left sum is right, but maybe I just need to check right sum really. Sum works. I guess this is the axis afterwards. Okay, so then you have this. You have to do -3 plus 2, so that's -1. That sounds right. Am I doing this? Oh, I double count the math. Huh. That's true. I double count the math on the periods. Okay, that's not that bad. Is this... okay, we can take it out from left sum, right? So we don't even care about this because that's the tiebreaker. And then we don't care about this because this is also the one that, not tiebreaker, overlap. Okay. Okay. YOLO. Definitely, probably wrong answer, but there's so many moving parts. Oh, okay. Yeah, not bad. Yeah, okay. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, explanation, everything in between. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye-bye.